It's nice to have you again, my friends, here on Will EduTech. Now, in the previous lessons, we have been looking at simplifying exponential or indices expressions. Okay, now in this video I'm going to be introducing you to exponential or indices equations now, my friends. Okay, so this is part one of our edition. So here it states, in an exponential or indices equation, the variable or the unknown, which we also call the letter, okay, the unknown or the variable is in the power. Okay, so let's just look at some quick examples just to reinforce what we're speaking about. Let's say you have a base m. Okay, let's use y. Let's say you had a base y, and base y is equal to base y raised to the n power. Okay, and that is equal to a base y raised to the m power. Okay, then if the bases are the same, okay, then it is safe to say then, my friends, that we can equate the powers. Okay, so here what we're saying, then if the bases are the same, then n must be equal to m. Okay, once we have the same base. So when working with an exponential or an indices equation, the objective is to get the same base on both sides of the equation. Okay, my friends, so that's basically it. That's all we'll be doing here. It's pretty much that easy. There's nothing much to it. So let's look at some examples now. Okay, just to reinforce these concepts. Let's say in example number 1, let's say we have a base 2 raised to the power of 1, and that is equal to base 2 raised to the power of x. Okay, if you notice the variable x, the unknown x, what we're trying to find, it's in the power. Okay, hence this is an indices equation. Now, since I have the same base, if you notice, my friends, I have the same base on both sides. This is a base 2 here, and this is a base 2. So once I have a situation where I can get the same base on both sides, then it is safe to say then x must be equal to 1. X must be equal to 1. Okay, so in this case the value of x is 1. All right, now let's step it up a bit. Hopefully you see the general idea there when looking at numbers. Let's look at example number 2. Let's step it up a bit. Let's say they gave us a 3 raised to the power of x. Okay, and that is equal to 9, and they're asking us to find the value of x now. Now, if you notice, by comparison, the bases aren't the same in this case. I have a base 3 there, and my base over here is 9. Now, what I'm asking myself, can 9 be written as a base 3, or how can I get 9 to be written in base 3? Now, a very important thing that you would have learned from earlier lessons is that, and I'll just make a note up here. We remember that 3 times 3 is equal to 9. Okay, and 3 times 3 is the same as 3 squared. Okay, my friends, because 3 is multiplying itself 2 times. And if you're not sure about these examples, I would recommend that you could take a look at the earlier videos in the lesson, okay, in the playlist rather, where we teach you the basic concepts of what is happening. So in this case, my friends, I can rewrite the base 9 as a base 3. So I could say 9 is the same as, so this would be 3 raised to the power of x, and 9 can be written in a lower base, and that's base 3 raised to the power of 2. Now if you notice, I have the same base on both sides. I have a base 3 here, and I have a base 3 there. Hence, then, in this case, my friends, in this case, then x must be equal to 2. Okay, because, and it makes sense, if I have a 3 here and I raise 3 to the power of 2, 3 times 3 is 9. Okay, so it really makes sense in that case. So in this case, my value of x would be 2. So just remember, this is just an introduction as to what is happening. Let's just look at something a little bit more complicated then. Okay, let's look at another example. Let's look at, this is example number 3. Okay, let's say they gave us a problem such as this. Let's say we have a 25, okay, raised to the x plus 2, and that is equal to 5 raised to the x power. Okay, Now it's basically simple again. As you can see in this case, my power is x plus 2 here on my left hand side, and my power over here is x, okay, raised to the x power. Now basically what I'm saying, my friends, can 25, if I notice I have a 5 on this side, I'm asking myself, can 25 be written as a base 5? I'm trying to reduce the bigger number to the lower base, okay? So basically we know that 25 is the same as 5 squared, okay? So I can just simply put that in a bracket, 5 squared. And if you notice, I have my power on the outside, x plus 2. So now this is equal to 5 raised to the power of x, okay? Now if you notice what is happening, I have the power to power rule taking place here. So the power that is, the power 2 here, that 5 is raised to, I'm going to use it to multiply the power outside the bracket, which is this power here, okay, my friends? So really, in doing that, I would have here now a 5, my base 5, but I would say 2 times x, that's 2x, okay? And 2 times 2, that's plus 4, okay? Now this would be equal to 5x. Now if you notice what is happening, I have a common base on both sides. I have reduced my bases to a base 5, my 25 to a base 5 rather. So there now I can simply equate the powers. I can say then 2x plus 4 must be equal to x, okay? So simply, let's solve for x. Let's just do it here. My equation is saying 2x plus 4 must be equal to x, okay? So by intuition, the 4 is positive on this side. So when I take it over, and you could always revisit our playlist on algebra on transposition, okay, if you're not sure what we're doing here. Now, if you notice, the 4 is positive here, so when I take it over, it simply means I must subtract 4 from both sides. So I have a 2x plus 4, okay? However, now I'm going to subtract 4, okay, my friends? Because I have to do the opposite of that to take it to the other side. So I have a x over there, and I'm going to minus 4. So I know that a positive 4 and a negative 4 will cancel out. Hence, I'm left with 2x is equal to x minus 4, okay? And then now, basically what I'm doing, I have to move the x to this side. So when I move the x to this side, the x now, it's a positive x on that side, friends. So when my x come to the left hand side, it will become a negative x. So basically I'm doing the inverse. If it's positive, then I have to do the opposite of addition, which is to subtract x from both sides. So I will have my x there, and I'm minusing, subtracting x, and I had a negative 4 over there. Now obviously, my friends, in this case, we know that 2x minus x will leave us with an x. So we have an x there, and this is equal to, we know a positive x will cancel out with a negative x, so we're left with negative 4, and that's our answer, okay? So the value of x here is negative 4, okay? And you could always substitute back the values for x to see if this equation remains true, all right? This was an introduction. Hope that this was useful. See you in the other videos where we'll be looking at some more interesting questions as it relates to indices equations. Bye-bye.